All right, so today we're going to start talking about functions. So it's kind of good because it gives you a little break from slope and all of that, but it's still looking at graphs and still looking at XY relationships in the coordinate plane. But this usually many students are like, oh, that's easy. And it's just a welcome little break, right? So let's go ahead and on a sheet of notebook paper, do this part together. So I just want to even talk about this word. So write this down and you're on notebook paper. So just a few things. So these are your notes. Part of them. Today's the 7th, I believe. And this is going to be saved in your folder. So what does the word function even mean? When you think about something functioning or how something functions, what does that mean to you? Just think about that. So, excuse me, sometimes people say, well, it's how something works. Or if something is functional or not. Right? So function can mean like, well, this is how something works. Or was that functional or not functional? So does something work well or not? And so that's kind of how we look at functions in math. Is it going to work or not? And so let's talk about a situation then. Let's say I'm just going to draw like a map. Draw this map with me. Let's say that here I am, Miss Fuentes, and I was asked at the same time in the day. So I was asked at 9:30 every day to go teach in room 400, my room. I was asked to go teach in room 200, and I was asked to go teach in room 104. So they said, hey, Miss Fuentes, at 9:30, go to all these spots. Is that going to work or not? For me to go to 3 different locations at the same time. Is that going to work? It's not, is it? This is not functional for one person to go to 3 different places at the same time. So this is what we're thinking about today when we're thinking about functions and not functions, okay? So this is a non-functional relationship, right? So this wouldn't be a function. So let's talk about this though. What if they said, oh, well, there's Miss Fuentes and Miss Williams and I don't know, let's use a different one, and Miss Lada. We still need you to cover teaching at 9:30, and it's still in these classrooms. But Fuentes, you'll cover 400. Williams, you'll cover 104, and Lada, you'll cover 200. It's all at 9:30, right? All at the same time. But now we have one teacher going to one location. Is that functional? Will that work? It will work, right? So this is an example of a functional relationship. So if we had to label them what's a function and not a function, this is a function because it's functional. This is not a function. So when we go apply this to math, look at what's actually going on here. There were some values here, and they each went to one other value, didn't they? Just one. That's functional. Here there was one value and it went to many. That's not functional. So when we think about the definition of functional and not functional, it's going to be that one value over here going to many is not a function. One value going to just one other value is a function. And these are actually going to be our x's and our y's. So when we have one x value and it's going to many, that's not functional, not a function. But if we have more than one x value or just one x value going to one other y value only, that is a function. Okay, that's the whole idea behind this. And when it's a graph, it's even easier to recognize because there's a way to check that. So this is the basics of function or not functioning or not functioning. So that was supposed to be a notebook paper. You could put that to the side. Now you need this paper out. And I'm sorry about that shadow. I'm in a different room recording this. But this is the page that you need next. So go ahead and put your name, the date, and the period. Let's see. And I'm just going to have you turn all this in today. I'll hand it back if you need it. But today we'll just have you all turn it in. Let me try to get a little closer here without getting that shadow on. Without getting that shadow too much on the paper. So identifying functions. So we just talked about it. So here's what it looks like. If you go to the bottom of the page, they give you x values and y values either in a table, or they give you x and y values in a list, or they'll give you a graph of x and y values, or they'll do like what I did and give you a map of x to y values. And the main ideas are this. A function is a rule that assigns each x value exactly one y value. So each x only gets one. So this is a function. A function assigns each x value exactly one y value. So that word exactly one is very important right here. So you'll see it applied in a moment. It becomes easier with practice. So it says functions occur when every x value is associated with exactly one y value. We could also call these input and output. So when your input has only one output. Okay. So that's just some quick notes on what is a function, right? So when you have tables and ordered pairs, so like number 1 and 2 at the bottom, to test whether or not a table or set of ordered pairs represents a function, look to see if each input or x value has exactly one output or y value. So we are still obviously talking about things on a graph and x and y values, input, output, but it's just a little different now. We're talking about is something a function or not. So this is how to test on a table or ordered pairs set. Is there only one y value to the x value? Is there only one output to the input? So how about on a graph then? Well, if a graph represents a function, it's going to be able to pass a vertical line test. So again, these are just some notes, but you'll be able to see how it works in just a sec. This means any vertical line drawn down the graph should intersect the graph at exactly one. Did I mess? Hold on, sorry. I thought my camera stopped recording. At exactly 1 point. So if you draw a vertical line to check whether a graphed function will pass the test, that vertical line should only cross at 1 point. And I'll show you that in a minute. You don't have to draw that line. If you did, sorry. Okay, and then mapping, that's like this down here, or what we did to introduce the lesson. Each x value must connect to only one y value. Make sure that there isn't more than one arrow leaving an x value. That's for it to be functions, okay? These are all the rules on how it can be a function. Basically, the x can only have one y, right?